where if I have the absolute value equal a number, I'll just use 4, we had to split this up for 2 cases, right? Had to split it up for x equal what's there, and I said you could use and or, right? X equals -4. Those were our 2 cases. Okay? Well, we're going to have the same 2 cases when we look at inequalities. Okay, so the first inequality we're going to look at is the greater than. If I have the absolute value of x, and again, I'll just keep with my example with 4, greater than 4, I still have my 2 cases. Now, what do you remember about working with inequalities? When you're doing inequalities, there was a rule. Yeah, when you multiply or divide by a negative number, the sign flips. You have to remember this. And I would suggest writing down these notes. When you multiply or divide by a negative number, and I stress by a negative number, you have to flip the inequality sign. Okay. Okay. So we're gonna solve this the same way almost. The thing that's the same is our 2 cases. Okay. I take what's inside. In this case, it's a greater than symbol, and set it equal to what's there. And unlike, here's a different part. Unlike the equation, I don't have a choice using the word and or. Okay? If I have a greater than symbol, or a greater than or equal to symbol, I have to use the word or. Yep, I have to use the word or. Okay, my second case. I take what's inside, set it equal to the opposite of what's there. Okay, -4. Yeah, I have to flip the sign because technically I'm multiplying that by -1. So I have to flip my sign. When I go to graph this, x is greater than 4, x is less than -4. The only thing I really have to have are my 2 points, 4 and -4. Negatives are on the left-hand side. Okay. Positives are on the right-hand side. So -4 is smaller than 4. Is it a closed circle? Open circle. Yeah, because it does not equal 4 or -4. So they're open circles. If there was a equal sign here, it would be a closed circle. And I want all those numbers greater than 4. So I get a shade greater than 4 and less than -4. So I'm going to shade -4. So in general, my greater than or equal to's are or statements and their graphs generally go out. Less than's are going to go in between. Okay. Yeah, it's going to shade in between the dots. And that's on page 2 or 3. So let's do a couple of examples. Okay, what's my two cases for number 1? Yeah, m is going to be greater than 10. M is going to be less than to negative 10. What goes in between? Or. Okay, well, they're going up by 2s. Okay, first of all, they're open circles because there's no equal sign. So here's negative 10. Here's 4, 6, 8, positive 10. My graphs are going to look like that for ors. Now, you could either shade it like that, or you could put an arrow up like that. I don't care. I used to do arrows, but I don't know why I started shading there. Doesn't matter. Yes, this is called the inequality statement. You will be using this, throughout Algebra 2 as well. So you might as well get used to saying it's the inequality statement. Let's do an equal one. How about number 4? Okay, my two cases. N is greater than or equal to what's there. This is a greater than, so it's an or. N, negative 8, and I have to flip this because of my negative sign. So, closed circles at 8. Yep, still going to go the opposite directions. Pretty easy, right? Okay, of course, just like you worked with equalities, you're going to have to get the variable by itself. Okay? Let's look at number 7. My two cases, take what's inside, a divided by 5 is greater than or equal to what's there. It's a greater than sign, so it's an or statement. Take what's inside, take the opposite of what's there, and flip the sign. Okay, now we've got two inequalities to solve. I have to get the a by itself, so I'm going to multiply both sides by 5, the denominator. Yep, 5's cancel, so a is greater than or equal to 5 times 5, which is 25. Do the same thing with the other side. Multiply by 5. And I get a negative 25. Now, please, this is what I mean by the word by. I am multiplying by a positive 5. So I keep the sign as is. Even though it's a negative number, I'm multiplying by a positive 5. Okay? If this was a negative 5, I'd have to flip it, but it's not. It's a positive 5. Okay, here's my inequality statement. If you want. Okay, so I've got negative 25, closed circle, because of the equal sign, positive 25. It's an or, so I'm going to shade directions going out. Only if you divide by a negative number. In fact, let's do number 12. It's a good question. Let's do number 12. Okay, case 1. Negative 6v less than or equal to 36. Oh, it's a less than sign. Yeah, I didn't think they had less thans until the next page. That's okay, we can do less thans. Okay, less than signs. If I have to use or for greater than or equals, if I have to use ors for greater than or equals, what do you think I'm going to use for less than or equals? This is a less than or equal to. I have to use the word and. Okay. Yeah. So number 10 is an and number 8 is an and. Because it's a less than or equal to. So I got to use the word and. Take what's inside. Set it opposite of what's there. But because I switched to a negative, I have to flip my sign. Okay, I have to get v by itself. So I'm going to divide both sides by negative 6. Now this time I am dividing by a negative number. So I have to flip that sign. Same with the other side. Divide by negative 6, divide by negative 6. So I get v, I divided by a negative number, so I have to flip my sign. Negative 36 divided by negative 6, positive 6. Okay. Let's see, I've got negative 6 and 6. Closed circle because of the equal sign. So closed circle at 6, closed circle at negative 6. This is an and statement. So we're not going to go opposite directions. We're going to go in between. All of these numbers in between the points make that statement true. So and statements are going to look like this. Either an open or closed circle, and we're going to shade in between them. That's an and statement. So there's a lot going on with inequalities. A lot more than just equations. So let's go up and do number 10. Gonna get 13? Okay, my two statements, take what's inside, 5 plus p, keep everything the same. I already identified this as an and statement because it's a less than symbol. And take what's inside, take the opposite of what's there, and then flip my sign. Okay. So now I have to subtract 5 from both sides of my inequality. P is less than 3, and subtract 5, P is greater than -8 minus 5 is -13. Okay, open or close circles. Open at 3. Ooh, I'm going to have to go in between. And open at -13, in between 12 and 14. And it's an and statement, so I'm going to shade in between my points. Easy peasy, right? Few things to remember. You know, which graph to use, whether it's in between or opposite directions, depending on that conjunction word, and or. And if you multiply or divide by a negative number, switch the sign or flip it. Let's see if we got any tricky. Yes, we do have some tricky problems.
Page 4.
Yeah, it starts with number 20. Okay. The problem is I can't do my two cases unless I isolate the absolute value first. So in order to get rid of a -5, the first thing I have to do is add 5 to both sides even before I split it up. Okay? So I get the absolute value of b. My 5's cancel to 0, is greater than or equal to -3 plus 5 is +2. Now that this is isolated, I can do my two cases. V is greater than or equal to 2. That's what's there. Now, is this an or an and statement? Or. And I don't decide whether it's an and or until this is isolated. Because whatever operation I have to do here, I may have to flip that sign. Okay, so only when this is isolated do you determine whether that's an and or an or. Take what's inside, the opposite of what's there, flip the sign. Okay, they're going to be closed circles at 2 and -2. It's an or statement, so they go opposite ways. Or opposite. Yeah, they start to get pretty complicated, especially when you get to page 5. Are there complicated ones on? Yeah, yeah. Let's do number 22. Okay, so I've got -8 times the I'm going to rewrite it. Absolute value of n is greater than or equal to -40. Now I have a mathematical operation here, right? Being multiplied. How do I undo multiplication? Divide by the coefficient. Think of that as a coefficient. -8, -8. So these cancel the 1. I get the absolute value of n, +5. But what happens with my sign? It flips. Because I divided by a negative number. Now, well, let's think about that for a minute. Our two cases, take what's inside, keep everything the same. Now, this is where I look at to determine what the word is, because my absolute value is isolated. It's an and, because this statement says less than or equal to. So it's an and. Take what's inside, the opposite of what's there, and flip my sign. Okay, they're going to be closed circles at 5 and -5 because of the equal signs. -5, +5. It's an and statement, so it's in between. Let's find a really tricky one here. Let's look at number 36. Looks like 36 has got everything. Okay, first of all, I got to work on getting the absolute value isolated, right? I'm going to rewrite this. More room down here. 3 plus 3 times the absolute value, 2k minus 2, absolute value less than or equal to 39. Yeah, let's get rid of this 3 out here. So let's subtract 3 from both sides. So I get rid of that 3. I get 3 times the absolute value, 2k minus 2, less than or equal to 39 minus 3 is 36. Multiplication between the 3 and the absolute value. So I'm going to divide by that. Think of it as a coefficient, 3. So I get the absolute value of 2k minus 2. The sign stays the same. It's dividing by a positive number. 36 divided by 3. 12. Now I finally have that isolated, that absolute value. So I'm going to split this up. 2k minus 2 is less than or equal to what's there. This is a less than or equal to, so it's an and statement. Take what's inside. 2k minus 2. Take the opposite of what's there and flip my sign. Looks like I'm still going to run out of room. Okay, add 2 to both sides. So I get 2k is less than or equal to 10. Yeah. Divide by the coefficient 2. So I'm going to rewrite it up here. So I get k as less than or equal to 10 divided by 2 is 5. And I have to solve the other one. Add 2 to both sides. 2k is greater than or equal to negative 12 plus 2 is negative 10. Divide by the coefficient 2. So k is going to be greater than or equal to negative 5. Now, I can divide a negative number without flipping the sign. If I was dividing by a negative number, I would have to flip it. Yes, ma'am. You're right. 12 plus 2 is 14.
Yeah. So 1 would be 7. The other 1 would be 5.
Oh, shoot. Oh.
That's why you're doing pencil. Yeah, just see if you're getting it.
That's right. Actually, there were 2. I thought I saw 2 hands. All right, let's graph it. Closed circle at 7. And closed circle at negative 5. And statement in between. I think it was a math teacher. It must have invented whiteout.
Actually, it's not.
Was it really?